Not really. I've been stressed trying to set off this thing. It hasn't been easy. God. God. Can we start? Ah, God. A lot of things on my desk. Can we start? Help us and share the group link, the live link to your departmental groups and all that, so that we can see how to make things easy for you guys. Let's see how to make things easy. Let's see how to make things easy. I believe you guys must have revised what we did last time on esters, also called the alkanoids, where we made mention of different things. So I'd like you guys to put much effort into this class. We're going to start once we hit up to 100 users live. So help us and share the link as fast as possible so that we can hit the 100 users and start. We're going to do magic tonight. Oh, God. Oh, God. Okay. Help us and share the link so that once we hit 100 users, we can start immediately. To your departmental groups, all groups you can think of, help us and share. All right. Think we should get started, right? We need to get things started. All right, we're going to start tonight with a topic: aldehydes and ketones. Organic chemistry. Organic chemistry. Don't mind my board. Starting with aldehyde, and ketones. Aldehydes and ketones. Let's do something tonight. Aldehydes and ketones. Should we start? If you want us to start, please put in the comment section. Let's get started. All right, all right, all right. All right. What is the first thing that comes to your mind when you hear the word aldehydes and ketones? What's the first thing that comes to your mind when you hear the word aldehydes and ketones? Any attempts? Any attempts? Put it in the chat box or the comment section so that we can start. What comes to your mind when you hear the word aldehydes and ketones? Aldehydes and ketone. All right, the first thing first. The first thing that should come to your mind when you hear the term aldehyde and ketone is this. There is presence of carbonyl group. There is presence of what? Carbonyl group. It should come to your mind. The presence of carbonyl group. That should be the first thing that should come to your mind. The presence of carbonyl group. Now the question is, what is a carbonyl group? That should be the question. What is a carbonyl group? What is a carbonyl group? When you hear the word a carbonyl, carbonyl, carbonyl group, the first thing that should come to your mind is carbon bonded to oxygen with a double bond. Are you with me? Carbon bonded to oxygen with a double bond. Carbon bonded to oxygen with a double bond. So once we have something like this, carbon bonded to oxygen with a double bond, automatically that should represent an aldehyde group. It should represent what? An aldehyde group. Or we have something written like this. It is also, that should represent a carbonyl group, a carbonyl group. Carbon bonded to oxygen with a double bond, that should represent a carbonyl group. Or the C here, bonded to the oxygen with a double bond above, that is also representing a carbonyl group. Now, I want you to remember something, that oxygen and carbon, they don't have the same electronegativity. Yes, they don't have the same electronegativity. So there is difference in electronegativity. That is what? Difference in electronegativity. Does that make sense to you? Now, for the fact there is difference in electronegativity, I have a question for you. In carbonyl group, do you expect the bond there to be polar or non-polar? Do you expect the bond there to be polar or non-polar? What is your expectation? What do you expect? Do you expect it to be polar or non-polar? Okay, yes. Yeah. You guys are there. For the fact they have different electronegativity value, both of them will form a polar bond. Now, this thing should give you an idea. If I ask you whether aldehydes and ketones are soluble in water, will you say they are soluble or insoluble in water? They mean the lower members. Will you say they are soluble or insoluble? Who is saying non-polar? They are supposed to be polar, not non-polar, please. Both will form a polar bond, not non-polar, please. So will you expect them to be soluble or insoluble? I'm listening. Drop your answer in the comment section. Do you expect them to be soluble or insoluble? The lower member should be soluble. So without saying anything much, you should know that the lower members of alkanals and alkanones are soluble or miscible with water. Does that make sense to you? Now, I have another point you should know. The next point you should know is this: that because this oxygen is more electronegative than carbon, the carbonyl group is what? Polar. Put that point down. That aldehydes and ketones contain a carbonyl group. Put that point down first. That aldehydes and ketones contain a carbonyl group. That's the first point you should know. That aldehydes and ketones contain a carbonyl group. That's the first thing. The second point is that because oxygen is more electronegative than carbon, the carbonyl group is polar. That's the second point. That because oxygen is more electronegative than carbon, the carbonyl group is polar. Have you gotten that? If you've gotten that, let's have in the chat box noted so that I can proceed. Have you gotten that? If you've gotten that, let's have in the chat box noted so that we can proceed. All right, let's move on. Now listen. Now I want to know this, that the polarity of this carbonyl group is what determines the chemical properties of these aldehydes and ketones. That the polarity of this carbonyl group is what determines this the reaction or the reactivity of these aldehydes and ketones. Do you observe something? That both aldehydes and ketones have a carbonyl group, and this carbonyl group is just a carbon bonded to oxygen with a double bond. And for the fact that oxygen is more electronegative than carbon, that carbonyl group is polar. Does that make sense to you? Now that will lead us to a question now. What is an aldehyde and what is a ketone? That should be the next heading. What is an aldehyde? Now I want to put these points down. That an aldehyde is an organic compound. I repeat, an aldehyde is an organic compound. Have you gotten that? So an aldehyde is an organic compound that contains a carbonyl group. It's an organic compound that contains a carbonyl group. Or you can say an aldehyde is an organic compound containing a carbonyl group attached to at least one hydrogen atom. I repeat, an aldehyde is an organic compound containing a carbonyl group that is attached to at least one hydrogen atom. That is attached to at least one hydrogen atom. That is attached to at least one hydrogen atom. Have you gotten that? Have you gotten that? The aldehyde is an organic compound that is attached to at least it's an organic compound containing a carbonyl group that is attached to at least one hydrogen atom. Now, what do I mean by that? Let's take a look at this. Look up. Now, this is a carbonyl group. Once it is attached to a hydrogen atom, we call it an aldehyde group. So once we have this CO and we have a hydrogen somewhere here, it becomes CHO. Are you with me? So this is represented as CHO. It's a bond waiting for something else to come. So once the carbonyl group is bonded to at least one hydrogen atom, we call it an aldehyde group. So an aldehyde is an organic compound containing a carbonyl group that is attached to at least one hydrogen atom. Does that make sense to you? Now, which means if we have here, so if we want to represent an aldehyde group, we can say RCHO. Or it will be written this way: R, carbon with double bond on oxygen and one bond on hydrogen. So anyhow you want to put it, it represents a carbonyl group. Are you with me, please? So we have this RCHO and we have this RCHO as well. So once the carbonyl group is bonded to at least one hydrogen atom, that carbonyl group will form an organic compound called aldehyde. Does that make sense to you? Now, if the carbonyl group is bonded to either two alkyl group or phenyl groups, we call it a ketone. But first point, let's focus on aldehyde for now. I say that an aldehyde is an organic compound containing a carbonyl group that is attached to at least one hydrogen atom. Have you gotten that? The next point I want you to know is this. In an aldehyde, the carbonyl group, in an aldehyde, put that point down, in an aldehyde, the carbonyl group is always at the end of the carbon chain. In an aldehyde, the carbonyl group is always at the end of the carbon chain. Very, very important. In an aldehyde, the carbonyl group, or you can say the carbonyl carbon. This is the carbonyl group. The carbon in the carbonyl group is called the carbonyl carbon. Does that make sense to you? In an aldehyde, the carbonyl carbon is always at the last chain, at the end of the carbon chain, please. Have you gotten that? So now, I will give you some examples now. Look at this. Now, is there something now that in an aldehyde, that a carbon, the carbonyl carbon, do you understand what I mean by carbonyl carbon? The carbon that is present in the carbonyl group. This is the carbonyl group, CO. That carbon that forms the carbonyl group is called the carbonyl carbon. It's always at the end of the carbon chain. Now listen, when you are at the end of a carbon chain, you are always counted as number one if you are a functional group. Are you with me? Which means we can never and ever have something like, should we say, butan 2R. You know that when we are mentioning aldehyde, okay, let's take it one by one. So that you will not be confused. That in an aldehyde, the carbonyl carbon is always at the word, at the end of the carbon chain. The next point you should know, there is difference between aldehyde and alkanal. There is difference between aldehyde and alkanal. I repeat, there is difference between aldehyde and alkanal. Now listen. A saturated aliphatic aldehyde is called an alkanal. Put that point down. I said a saturated aliphatic aldehyde is called an alkanal. Help us and share the link to the live so that we can proceed. Share the link so that others can join. A saturated aliphatic aldehyde is called an alkanal. A saturated aliphatic aldehyde is called an alkanal. You know what I mean by saturated? What they have is carbon to carbon single bond. They are saturated. Are you with me? Alkanal, from the word alkane. Are you with me? That's good. Okay, now let's look at this. If we have these examples now, but if we have this carbonyl group, CO, and there is no hydrogen attached to it, what is attached to it is just carbon only. Hey, look at this. This R represents a what? An alkyl group, right? Alkyl group are made of carbon. Hope you are aware. Alkyl group are made of carbon. That means here, in the carbonyl group is bonded to an alkyl group, which is a carbon chain, and hydrogen. Once the carbonyl group is bonded to hydrogen, it is an aldehyde. When the alkyl group is saturated, it is an alkanal. That's why I say that once we have a saturated aliphatic aldehyde, we call it an alkanal. Don't forget this. Now, when we have this carbonyl group, but it's not bonded to hydrogen, you don't call it an aldehyde again. It becomes a ketone. It becomes a what? A ketone. So once we have this and this, but what is present is not a hydrogen atom, we don't call it aldehyde group again. it becomes a keto group. So we have R and another R. For the fact we have different R, we can call this one R prime. Are you clear now? So for the fact in aldehyde, we represent it as RCHO. But here we represent RCOR prime. Does that make sense to you? RCOR prime. Very, very important. RCOR prime. There is difference between these and esters. In esters, we represent them with RCOOR prime. This is for esters. This is for what? Ketones. Don't forget this. That the first one, this one is for esters. Why this one is for what? Ketones. This is for esters. Why this is for what? Ketones. Are you clear, please? Please don't make this mistake. Now, what's the lesson we need to know? The most important thing you should know to differentiate these is that once you see a carbon chain on both sides of the carbon holding the oxygen, it is not an aldehyde. It is not an alkanal. It is a ketone group. Are you with me? Also called alkanone. So I want you to also write this point down, that a ketone is an organic compound. Put this point down. A ketone is an organic compound. A ketone is an organic compound containing a carbonyl group. A ketone is an organic compound containing a carbonyl group. A ketone is an organic compound containing a carbonyl group. Have you written that? That is attached to two alkyl or phenyl groups. That is attached to two alkyl or phenyl groups. That is attached to two alkyl or phenyl groups. Have you gotten that? If you have gotten it, put noted so that I will proceed. That is attached to two alkyl or phenyl groups. Okay. I mentioned two things there. That is attached to two. I want to show you something now. I want to show you something. If you want me to show you, just type in the comment section, show us. Let me show you something. You may not have seen it in your textbook, but let me show you. You want me to show you? Let's put in the comment section, show us, so that we show you that. Now listen. You see this formula I wrote on the board? This general molecular formula, RCOR prime. We can modify it. That thing is showing that it is for aliphatic. You know that when you classify hydrocarbon, you have aliphatic and aromatic hydrocarbon. Oh God. Do you get what I'm saying? When we classified hydrocarbon, we have aliphatic and aromatic. Under aliphatic, we now have saturated and unsaturated. Under saturated, we now have alkane. Under unsaturated, we now have alkene and alkyne. Hope you are aware. Hope you are with me. If you are with me, type "I'm with you" so that we will proceed. Hope you are with me. Okay, now listen. So here, they are putting R. If you want to cause trouble now, I'll go to this board and write something like this. ARCOAR. This AR is representing aromatic. It's representing what? Aromatic. Are you with me? And anytime, example of the aromatic I'm talking about is benzene ring. Is what? Benzene ring. Are you with me? Benzene ring. When this benzene is serving as a branch or is attached to a functional group, it is called phenyl. It is called what? Phenyl. P-H-E-N-Y-L. Phenyl. It's called phenyl. P-H-E-N-Y-L. Phenyl. Very, very important. Phenyl. 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 Are you with me, please? So, but now we are using R because we are referring to the aliphatic and not the aromatic, where R is serving as an alkyl group. The R is serving, this is serving as phenyl group, while this is serving as a what? Alkyl group. A-L-K-Y-L, alkyl group. Very, very important. Very, very important. So that is why I said that a ketone is an organic compound containing a carbonyl group that is attached to 2-phenyl or alkyl group. Are you with me? If it is attached to an alkyl group that is saturated, we now say that this ketone group is a saturated aliphatic ketone. And that saturated aliphatic ketone is what you call alkanone. What you call what? Alkanone. So which means anytime we have a ketone that is saturated, we now call it what? Alkanone. So that's why I call this aldehydes and ketone, or you say alkana and what? Alkanone. Very, very important. Take note of that. Take note of that. Take note of that. Take note of that. I say that saturated aliphatic aldehydes are called alkana, but saturated aliphatic ketones are called alkanones. Somebody says small. I will not even say anything. I say small. I'm not even saying anything. We are just starting the engine. We have not started moving. By the time we start moving, we start going into reactions. I hope you have the strength to stay with me the end of this journey. Okay, let's proceed. Someone say recap. Should I recap? I said something about, I was just trying to differentiate aldehydes and alkanal. Aldehyde just in general. Do you get? When we have an aldehyde that is a saturated aliphatic, we call it alkanal. Do you get? Look at what I mean on the board. Look at what I mean. Look at this. When this young man is a saturated aliphatic, we call it alkanal. But when this young man is saturated aliphatic, we call it ketone. Sorry, we call it alkanone. So that's why I said that saturated aliphatic ketones are called alkanones, but saturated aliphatic aldehydes are called alkanal. This one has the formula RC, double bond O with hydrogen, also written as RCHO. While this one has RCO R prime, or you say RCO R prime, anyhow you want to say it. All right, let's proceed. Okay. Can we proceed? Okay. Can we proceed? All right. Now I have a question for you. Let me know if you are smart enough. Let me know if you can think. I have a question for you. Put this question down. The question says, Which of the following is a member? Which of the following is the first member of the series Alkanone? Which of the following is the first member of the series Alkanone? Which of the following is the first member of the series Alkanone? Option A, methanone. Option B, ethanone. Option C, propanone. Option D, butanone. What's the answer? The first member of the series Alkanone. What's the answer? Option A, methanone. Option B, we have ethanone. Option C. Now, if you look at the charts here, you will notice something. A lot of people are writing methanone, because they hear the word first member. They heard the word what? First member. Are you with me? So most people are writing methanone because they heard the word what? First member. Because they have been taught that one in organic chemistry is what? Met. So who is the first member for alkanones? Who is the first member for alkanones? It's very, very simple. I told you guys something. That in alkanones, we have R, CO, R prime, right? That R must be there. That R is a carbon chain. So if we have carbon here and we have carbon here, what is the minimum number of carbon you will see in alkanone? What is the minimum number of carbon you will see in alkanone? Is it 1, 2, or 3? Which one? 1, 2, or 3? Someone said 2. Look at this. We already have carbon before, which is CO. The carbonyl group is always present. This carbonyl group is always present. Are you confused? Okay, let me illustrate it. Let's look at this. Let's look at it. What is the functional group for alkanone? A ketone group, right? Which is CO. So we have CO. Now this R represents what? Alkyl group, right? It represents alkyl group. Do you agree with me? An alkyl group are represented with the formula what? CnH2n plus 1. That means carbon must be present. So these people are represented with CnH2n plus 1. This is also CnH2n plus 1. This C represents what? It's not carbon. So if you look at this now, how many carbon are you seeing? Minimum. It was 1, 2, 3. Does that make sense to you? So the minimum, the first member in alkanone is propanone. Is what? Propanone. Also called propan-2-one. So we call it acetone. So who is the first member now? Propanone. Take note of that. Take note of that. Are you clear, please? The first member is what? Propanone. Don't make that mistake of saying it's methanone. We don't have anything like methanone. But we can have methanol. We can have ethanol. We can have propanol. But what we have is propanone, also called propan-2-one. So we call it acetone. I mentioned 3 names now. So the first member here, we have carbon already, is C. If we put 1 here, it becomes CH3, right? Because 2 times 1 is 2 plus 1, 3. Bonded to C, double bond O, bonded to CH3. So this is propanone. Or you call it propan-2-one, or you call it acetone. I mentioned 3 things now. Propanone, propan-2-one, or what? Acetone. Very, very important. This is for alkanone. Are you with me? But when it comes to alkanals, let's watch this. When it comes to alkanals, we're going to have something like this. The first member is, we have CHO is the functional group, right? The first member is HCHO, and that person is called methanol. So the formula of methanol is what? HCHO. Very, very important. HCHO. Now we have the other one, which is the second member, CH3CHO. How many carbon are there now? 2. In some cases, it will be written as this. It will be written this way. It will be written this way. Let's look at this. CH3 bonded to C, double bond O, bonded to H. Anyhow you see it. CH3 bonded to double bond O, bonded to H. Are you with me? So both of them represent the same thing. And what's that? Ethanol. So I might ask you a question. Why are we not saying something like this? Ethan-1-al, ethan-2-al, and all that. The alkanides, the functional group there, always serve as carbon 1. Don't forget this thing. Always serve as carbon 1. Always serve as carbon 1. Does that make sense to you? So the first point I said last time is that the first member of the series, alkanone, is propanone. Or you say propan-2-one, or you say acetone on the board. Propanone, propan-2-one, acetone. When we can boldly say propanone, because no matter how you count it, it's still number 2. There is no way you will count it for the last carbon not to get position 2. So in alkanone, we are having the position of the functional group. But in alkanals, we are not indicating the position of the functional group. Very, very important. So that will take us to the topic that says IUPAC nomenclature of alkanals. Let's start that. IUPAC nomenclature of alkanals. That should be the first heading. IUPAC nomenclature of alkanals. IUPAC nomenclature of alkanals. Have you gotten that? If you've gotten it, just say noted so that we can proceed. Well, Chris is stopping the chat for now. Well, Chris is stopping the chat for now. All right, that's by the way. IUPAC nomenclature of alkanones. Okay, should I start with alkanones or alkanals? Okay, of alkanals. Let's start with alkanals. IUPAC nomenclature of alkanals. Now put this point down. In alkanals, the carbonyl carbon of the functional group. In alkanals, the carbonyl carbon of the functional group is always numbered 1. In alkanals, the carbonyl carbon of the functional group is always numbered as 1. Have you gotten that? The carbonyl carbon is always someone typed after tonight you see your heavenly baby. You should stop distracting me. The carbonyl carbon of the functional group is always numbered 1. Now, we have noted that. Now, let's proceed. Look at this. CHO. The functional group there is CHO. That's carbon there. That's carbon that is in this functional group is called the carbonyl carbon. It's called what? The carbonyl carbon. Are you with me? It's called the carbonyl carbon. So now this is this. The carbonyl carbon. It's always numbered 1. Since we have numbered this one, there's no other carbon. So we have methanol. So there is no way it is hard once it is still all these saturated aliphatic ketones, saturated aliphatic aldehydes, also called alkanals. This thing will always end with R, position 1, position 1. So we can't have metan 2R. It's not possible. Are you with me? Because that carbon that is forming the functional group is always numbered 1. Just like in carboxylic acid. That's COOH. The carbon holding that functional group is always numbered 1. So here, you don't have to come and start numbering from this side. 1, 2. No, don't try it. Very, very important. So you number from this carbon. The carbon of the functional group. This is 1 and 2. So it is ethanol. So even if you have a branch, the numbering should start from this person. Not that if you want. In this case, you don't want your opinion. You must obey the rule in organic chemistry. Does that make sense to you? So if we have this now, CH3, CH2, and CHO, or it will be written this way, CH3, CH2, so we just put the bond, double bond O and 1 hydrogen. Anyhow you see it. Both of them. Where do we count from? Should we start from here? No. We are going to start from here. 1, 2, 3. So this is prop. 3 is prop. So we call it proper now. So any of these will represent the same thing, proper now. Don't need of telling me it is proper 1R. We know that it is always at position 1. So we say proper now. Does that make sense to you? Put these 3 examples down. This is example 1. This and this together form example 2. This and this together form example 3. I have to scatter that in case they split it for you guys so that you understand they are still writing the same thing. Are you with me? I will give you the one to write. When you're done writing this on the board, just type proceed so that I can give you the one to attempt. When you are done, just type proceed so that we'll give you what to attempt. So we'll give you what to attempt. Are you done? Okay, someone has given us proceed. I hope you are following what I'm saying. I hope you understand what I've said so far. Do you get me? Should I proceed? I hope you are with me. If you're with me, just type I'm with you so that I can proceed. I want to be sure that you have a good understanding on this topic. So that anytime you spend your time to come live with me, you have a reason to say, yeah, it's not a waste. You should understand. I'm the one teaching you. You should understand. You have to understand. You don't have any other option than to understand. Okay. So anytime where I sit on this my throne, you get the point. You should understand. I've spent time trying to carry you along on this introduction. We don't want to rush the topic. We want you to understand it step by step. So before your exam time, you must have captured everything. You have no reason not to score 90 something over 100 this semester in organic chemistry. You don't have any reason. Unless you refuse to make yourself available. Advise your friend to always be with us on live. I may not have time to be saying all these things in class. And any topic I've done on live, I don't know. I don't know. I didn't say anything, Okay. Okay, we have done this. Now I want to give you something to attempt. You will attempt that while I will get back to you guys. Attempt this. This question, let's, I don't know, the seems network is trying to interrupt. All right. Attempt this question. We have, okay, let's use this side. Attempt this. CH3, CH, CH3, CH2, CHO. What it will be the answer? What it will be the answer? CH3, CH, CH2, CHO with CH3 here. What it will be the answer? I'm waiting for your time. What it will be the answer? I'm waiting, I'm waiting, I'm waiting, I'm waiting. Clinton and Joko typed Almighty Oracle. That God be Almighty. Okay. What is will be the answer? Someone said 3-methyl butanol. Someone said 3-methyl propanol. Someone said 2-methyl butanol. Someone said 2-methyl propanone. Attempt the question. Attempt it. So that when I start the correction, you will not find it difficult. Someone said 2-methyl propanol. You deserve a knock. Use the very dimension propanol. Or. Are we talking about alkanol here? You see OH group. Someone says the question is strong. The question is not strong. Even if the question is strong, you have to be strong to attempt the question. Look at it. You have a functional group. First thing to do is to identify the functional group. Which functional group is there? CHO, right? Having a CHO is an aldehyde group, right? The name should end with AL. Al. So anything you are saying that is not ending with AL, you are saying something that is not correct, please. Very, very important. You're saying something that is not correct. Now let's tackle it. First thing first, identify the functional group. CHO. That CHO, what is called AL. It is called what? AL. AL. This is the functional group, AL. Now, if you look at it, you will notice that the longest continuous carbon chain is 4. Right? I repeat, the functional group here is, okay, let me, let's apply on the orachogenic flow. I don't like applying this online. Let's proceed, please. Let's proceed. I don't want to apply this online. If you need that, you come and pay me separately, I will teach you. Let me do that. Let me use your normal method. 1, 2, 3, 4 is Bruce, right? So this is R. We call it butanol, right? Butanol, right? But we have a CH3 here, right? Serving as a branch. Now, the mistake here is that some we call it 2-butanol, 2-methyl-butanol. Why some we call it 3-methyl-butanol? How? Some we number from the left-hand side and they will say 1, 2. That is 2-methyl-butanol. So some we say 2-methyl-butanol. So that this can be your option A in exam. And once you click it, you will fail it. You'll be thinking that you got it. Why some we obey the rule that says the carbonate carbon of the carbonate carbon, we always maintain position what? 1. So if this is position 1, this will become position 2, position 3, position 4. So this branch now, methyl group, is at which carbon? Carbon 3. So the name is 3-methyl butanol. So the correct answer is 3-methyl butanol and not 2-methyl butanol. Please, you must start from the functional group. The functional group has carbon. So you must number it first before any other numbering. You number from the functional group. Very, very important. Okay. I have another example. I would like you guys, you have written this example down, please. Write this example. The name is 3-methyl butanol. You put bracket reason, number the carbon from the functional group. Number the carbon chain from the functional group. Number the carbon chain from the functional group. Okay. What if we place 10,000 naira for the most active tonight? Very good. You must have written this, right? Must have written this. Should he write on? Okay, I've seen noted. Let's proceed. Put this example down. Put this example. Which example will I give you guys? Which one will I give you guys now? Okay. Take a look at this. Look at this. CH2, by the side we have Br, CH3 down. Here we have CH3 down, CH2, CHO. Yeah. Yeah. What's the answer? We have CH2. That is bromine by the side, please. We have CH here with CH3. We have CH with CH3. We have CH2. And we have CHO. What's the answer? What's the answer, please? Hello, Fountain. What's your question? Hello, Fountain. Do you have any question? Because someone said 5-bromo 3,4-dimethyl pentanol. Someone said Chimobi said 5-bromo 3,4-dimethyl pentanol. Princess Okendi said 5-bromo 3,4-dimethyl pentanol. Oleberita said 4-bromo 3,3-dimethyl butanol. Patrick said 5-bromo 3,4-dimethyl pentanol. Emmanuel 5-bromo 3,4-dimethyl pentanol. We are having much of 3,4-dimethyl pentanol. Let's check whether it's correct. Okay, let's look at that. Let's look at that. Okay, let's look at that. We have this. First thing first, identify your functional group. That is CHO. That will be our number 1, number 2, number 3, number 4, and number 5. So everything I'm doing must end as pentanal. Anything I'm writing must end with pentanal. Pentanal. Now we have branches here. Bromo, methyl, methyl, right? The bromo is on position what? 5. So the name should be 5-bromo. We have 2 CH3. Each CH3 is called methyl. It's called what? Methyl. But because there are 2, one is at position 3, the other is at position 4, we now say 3,4-dimethyl. We now say what? 3,4-dimethyl. So the name of this is at position 5, 5-bromo. 5-bromo. The first methyl group is at position 3. The one is at position 4. We are numbering from the CHO. Please. We are numbering from the CHO, which is the functional group. I said that at the beginning of the class, when naming an alkana, the carbonate carbon is numbered first. So we have 5-bromo, 3,4-dimethyl, pentanal. Let me make it more legible, please. Let me make it more legible. So this is 5-bromo, 5-bromo, 3,4-dimethyl, pentanal. 5-bromo, 3,4-dimethyl, pentanal. Have you gotten that? Have you gotten that? Have you gotten that? Should I proceed? Should I proceed? Should I proceed? All right. Now the next thing. Let's go to the next thing. Another point I would like you to know. Note this point. When the aldehyde group, when an aldehyde group is attached directly to a benzene ring, when an aldehyde group is attached directly to a benzene ring, it is called benzaldehyde. Which one is, can we switch our brain after exam? You can collect it back. I don't want to laugh. Allow me to focus on this life, please. I repeat, when an aldehyde group is attached directly to a benzene ring, it is called benzaldehyde. Benzaldehyde. If I want to deal with you now, I will throw this question. The simplest aromatic aldehyde is dash. The simplest aromatic aldehyde is benzaldehyde. The simplest aromatic aldehyde is benzaldehyde. Anytime you have a benzene ring and you have an aldehyde group, what's an aldehyde group? Is it CO or CHO? An aldehyde group is what? CHO. Attached to it, you call it benzaldehyde. My friend those days, we use his emotic language and call it benzenaldehyde. You get the point? We use that his emotic pronunciation and call it benzenaldehyde. I said, no, it's not benzene, it is benzaldehyde. So we call it benzaldehyde. Look at this. So we have the benzene here. Combined with this CHO. This is benzaldehyde. Benzaldehyde. ALDE. Benzaldehyde. Okay. Benzaldehyde. Okay. So once that should come again, only Christ will come again. Said this is the benzaldehyde here. Now, that is something that makes me coming to teach organic. I'm the one. Look out. I want to show you something. I want to show you. In benzene ring, there is what is called auto position, meta position, and para position. Again, auto position, meta position, and para position. 1 and 2, auto position. 1 and 3, meta position. And 1 and 4, para position. I don't know if you get the gist. You get the gist? Are you with me, please? Are you with me? Are you with me? Should I proceed? I repeat, 1 and 2, auto position. 1 and 3, meta position. And 1 and 4, para position. Para position. Somebody para. I want to release an album tonight too. I just want to be in my normal mode before I will go into that my upper echelon and release an album for you guys. So, once you have a benzene ring, how? Oh, someone asked me a question that said, when should we apply this? And I'm saying, you apply it in a disubstituted benzene, a benzene that has two substituents, two things attached to it. That's why you start mentioning auto, meta, and para. Sometimes in textbook, you will see something like this. O something. This O means auto position. This M something. M means meta position. We have P something. This P means para position. So when are you going to say that they are in auto, meta, or para? Once the one is at position 1, the other is at position 2, we call it auto. When it's position 1 and 3, meta. 1 and 4, para. 1 and 2, auto. 1 and 3, meta. 1 and 4, para. Let's go there. 1 and 2, auto. 1 and 3, meta. 1 and 4, para. So if I have this, look at this. And I attach something. Remember, I've written this, benzaldehyde. So if I have something like this, let's say CHO. And I have a hydroxy group here. Someone asked you to name this. Hydroxy group. This is now position 1. This is position 2. This is position 3, 4, 5, and 6. I can name this thing. You know that without this is called benzaldehyde. True or false? You remember now, when a benzene ring is attached to the aldehyde group, we call it benzaldehyde. Are you with me? So now, this thing, we're going to call it, we're going to name it. This is position 2. 2-hydroxy. Can you see that? 2-hydroxy benzaldehyde. 2-hydroxybenzaldehyde. 2-hydroxybenzaldehyde. That's the name. Because the hydroxy group is on position what? 2. Immediately, the carbon, this one is serving as position 1. This is serving as position 2. So we ask, why can't hydroxy group be the position 1? Not possible. Because this one will supersede it. Okay. Or we call it, if we don't want to use the word 2-hydroxy, we can say alto. Because position 1 and 2 is represented with what? Alto. We can now say O-hydroxy. Alto, that alto can be represented with O. O-hydroxy benzaldehyde. Some old textbooks normally use this, O-hydroxy benzaldehyde. Why some will use this, 2-hydroxy benzaldehyde? Anyone you see, both are correct. Okay, please put that point down. The first point says that when an aldehyde group, an aldehyde group is bonded directly to a benzene ring, we call it benzaldehyde. Okay. Next point is that in a disubstituted benzene ring, position 1 auto is used for position 1 and 2. Auto is used for position 1 and 2. Meta is used for position 1 and 3. While para is used for position 1 and 4. Auto 1 and 2. Meta 1 and 3. Para 1 and 4. Okay. Let's proceed. Okay. I have another point you should know. Remember I said that when the aldehyde group is attached to the benzene, we call it benzaldehyde, right? Now write this point down. When the carbonyl group, of an alkanone, is attached to a benzene ring, it is called a phenone. Phenone, Phenone, yeah, phenone. It is called a phenone. Have you got it? I didn't say phenol, please. I didn't say phenol. Well, we use, you know what that means? In Nigeria, you know what this means. Those are abroad may not understand. You know what this means? In this West African country, you know what this means? Okay. Smell please. Let me just okay. When aldehyde is bonded to benzene, we call it benzaldehyde. But now we are using the keto group, the carbonyl group of a ketone, of an alkanol. What the carbon is, this is RCHO for aldehyde or alkana, C double bond O with R prime, and R here for alkanone. Right? Are you with me? Now, if we come here and remove this and bond this thing with a benzene ring, it is called phenone. So this is called a phenone. But this OH is called phenol. Take note of the differences. Phenol and phenol. Phenol and phenol. Take note of that, the differences. Phenol and phenol. Phenol and phenol. When the benzene is attached to a hydroxyl group, we call it phenol. When it is a carbonyl group of an alkanone, we call it what? Phenol. There is something else I want to tell you. Should I tell you? Put in the chat box, tell us, so that I will tell you something. Put in the chat box, tell us, so that I will tell you something. If you're on this live, please like our this thing. Give us a thumbs up so that we can proceed. Okay. Since they said I should tell them, let me tell them. Let me tell them. Now listen, we have seen a phenol. The next I want to tell you. Remember, we have another R that needs replacement. If we take this carbonyl and bond it to two benzene ring. Are you with me, please? If the if the carbonyl group for an alkanone is attached to two benzene ring, it is called benzophenone. That is, if we have something like this, we have, okay, let's say we have this. Okay, let me put it in the way that what is, okay, O. All right, you can see that, right? You can see that. You can see that, right? This. We're going to call it benzophenone. This is benzophenone. This with this is a phenol. This is a benzene. We call it benzophenone. You now ask, why are we writing in this slant form? Both of them are correct, but I put it this way just to accommodate space. Okay. You can also draw it this way. Okay. Okay. Carbon, double bond O. Both of them are correct. Benzophenone. The first point says, when a carbonyl group of an alkanone is attached to a benzene ring, we call it a phenone. But when it is attached to two benzene rings, we call it benzophenone. At least you have seen how to write benzophenone, how to draw the structure of benzophenone. Benzophenone. Very, very important. Please don't forget that. Benzophenone. Don't forget that. Benzophenone. The next thing. Next, I want to ask you. I have a structure I will give you guys. Then you now tell me the name. The name. Look at this. Tell me the structure. We have this C. Benzene ring. We have double bond O, and this is bonded to CH3. Yeah, double bond O bonded to CH3. What's the name? What's the name, please? Give it a try. What's the name? What's the name? I'm waiting for you guys. Someone said benzo 2-methyl phenone. Only God knows what you guys are saying here. Methylphenol. Okay. Someone said benzene phenone. Okay. Someone said methylbenzophenone. Why benzophenone? You don't have to use benzophenone. Benzophenone is when we have two benzene on the carbonyl group. You don't have to use benzophenone at all. You don't have two benzene ring there. So why the benzophenone? Someone asks, why is the structure? Okay. Have you heard of acetyl before? Acetyl group. Acetyl. I believe is once we have at least 2 carbon, right? This alone is phenol. Are you with me? Are you with me, please? Now listen. This we have 2 names. It's either you call it acetophenone, or you say 1-phenyl ethanol. I repeat, acetophenone or 1-phenyl ethanol. Acetophenone or 1-phenyl ethanol. Have you gotten that? Have you gotten that point? Acetophenone. Noah Chris is still topping the chart, followed by Prince Okay. A lot of people in the same position. Okay. I said acetophenone, or you call it 1-phenyl. Phenyl is like once the benzyl ring serving as a branch, we call it phenyl. Does that make sense to you? Phenyl. So 1-phenyl ethanol, or you call it acetophenone. Have you gotten that? If you have gotten that, just say noted so that we'll be taking notes of what we've done before we move on. Have you written that? Okay, someone should drop another one. Let's try. Okay. All right, let's drop another one so that you can try. Now we'll just go to that structure and modify it. That's all I will do. Okay, let's have this structure. Before you know it, we are done with your textbook. Before you know what is going on, we are done. I want a situation whereby for this exam, when we are done with most of the topics here live, we are going to come up and have live interaction, live revision. I'll be throwing questions, you'll be answering. You get that's will that will help you to know how far you've gone in organic chemistry. I want you to be the best because the person teaching you is the best in the game. So you have to be the best. That's the first thing you must know. So a lion should give birth to a lion. So the sons and daughters of the oracle should be like the oracle. Let's go. Now we have this. Look at this structure. Bonded to C, double bond O, CH2, and another CH3. See the difference? Some of the structures I'm drawing, let me tell you this. Some of the structures I'm drawing, some of them are not in your textbook. Yes, some are not there. Now, I want you to know them. So I mentioned acetophenone, one also called 1-phenylethanone. Attend to this. So one say 1-phenylbutanone. Why saying boots? These American one are there. American one are there. One phenylpropanone. That is from Choma Boniface. Incredible. You are absolutely incredible. 1-phenylpropanone from Wolf Emmanuel. Incredible. 1-phenylpropanone from Regina. Incredible. 1-phenylpropanone from Emmanuel Kelechi. Incredible. You guys are amazing. You guys are amazing. You guys are amazing. You guys are amazing. I'm impressed. I love that. So we're going to call it, this we called propiophenone or 1-phenylpropanone. We're going to call it propiophenone. Propiophenone or 1-phenylpropanone. We're going to add 3 carbon. 1, 2, 3. 1-phenylpropanone. 1, 2. 1-phenylethanone. Have you gotten that? Have you gotten that? So which one is propio? Hey, God of Israel. Which one is propio again? that's like old name, please. The same way you say, how will I put it for you? Hey God. The same way you say propanoic acid. The same way you say propanoic acid. We can call it propionic acid. So I can't see the writing. Which one? Look at this. Let me write it again. All right. We have propio. P-R-O. P-I-O. Propiophenone. P-H-E-N-O-N-E. Propiophenone. Or you call it 1-phenyl. 1-phenyl. Phenyl propanone. 1-phenyl propanone. But if you can see them now, propiophenone or 1-phenyl propanone. Propiophenone or 1-phenyl propanone, please. All right. From today's forth, call some people propiophenone. That's a benzene ring that has. All right, that's by the way. Acetophenone and propiophenone. 1-phenylethanone, also called acetophenone. 1-phenylpropanone, also called propiophenone. Very, very important. Propiophenone. There are some things I'll mention in organic chemistry. You may not have. It looks as if we are speaking French. Who is this? Let's proceed, please. Let's proceed. Propiophenone. Acetophenone. I want to ask you a question. Should I ask you guys? There's a question that came to my mind. If you have these, what will you call it? Let me ask you this question. Let me see how good you are. If you have these, C6H5, okay, H5 bracket 2, C double bond O. What are we going to call it? Who has an idea? Someone say benzophenol. It is not phenol, not NOL, please. Someone say 7-hexanone. If I do you, if I do you like this, you know what that means in West Africa, right? If I do you like this, you know the correct answer by force. Hey God. Someone say methyl benzyl. Who is saying all these things? Ujumwa Vivian, are you lost so that we can carry you along? Use this. This is C5, C6H5 bracket 2, C double bond O. I'm waiting for your answer. Someone say tridecanone. God, we is diphenone. We is teaching these people. Damn, I'm shocked. Docanone. God, I've heard things tonight. Things that are not in existence, I've heard it tonight from you guys. You are creating unimaginable organic compounds. Benzophenol. Hey, get it. Let me tell you something. This is called benzophenone. It is called benzophenone. I just remove those structures. Listen, let me show you something. This is the same thing as saying the same C6H5 is in two places. Same thing as saying C6. Same thing as saying C6H5 bonded to C double bond O. There are two. C6H5, C6H5 as well. What does this represent? It represents two benzene rings. They are bonded. That means they are now serving as phenyl. You may ask yourself, you may ask me that benzene is C6H6. I know, but that one of the hydrogen has been removed so that it can bond to carbon. That makes it C6H5. Is that clear? So this is like phenyl group. So this is like, it's the same thing as saying something like this. Bonded to C double bond O. Bonded to C. So this is benzophenone. Or suppose the three of them still represents benzophenone. Benzophenone. Interesting and fantabulous. I saw that comment. Absolutely given. From Uguruchimobi. Are you clear now? Do you understand? Do you understand this? If you are clear, please say yes, sir, so that we can proceed. If you are clear, say yes, sir, so that we can proceed. Okay. Now, hope you know that these aldehydes and ketones are like 2-in-1. Yeah, they're like 2-in-1. So we are trying to hold both sides. But before we move on, I would like to bring your memories back. I would like you to remember what we said at the beginning of the class. Now, both aldehydes and ketones are carbonyl compounds because they contain what? Carbonyl group. And when we say carbonyl group, we mean C double bond what? O. Are you with me? That means we have carbon and oxygen. Now, since oxygen is more electronegative than carbon, the carbonyl group is polar. The carbonyl group is what? Polar. Are you with me? And it is this polarity that is responsible for many of the characteristic reactions of aldehydes and ketones. So, in exam, they may ask you, what determines the chemistry of aldehydes and ketones? The answer is what? Carbonyl group. The answer is what? Carbonyl group. Does that make sense to you? Now, the next thing I asked was an aldehyde. It's an organic compound containing a carbonyl group that is attached to at least one hydrogen atom, right? And once we have a saturated aliphatic aldehyde, we call it what? Alkanal. And that means we represent aldehydes or alkanal with RCHO. The carbonyl group, which is CO, must be bonded to at least one hydrogen. Now, when we made mention of ketone, we said they are organic compound containing a carbonyl group that is attached to two alkyl groups, R and the R, or you say two phenyl group. Are you with me? Now, when the carbonyl group in alkanol is attached to two benzene, we call it benzophenone. Are you with me? Now, the most important thing I want you to hear here is that the carbonyl group, which is present in aldehyde and ketone, or you say which is present in alkanals and alkanones, they are polar, which means they will dissolve in water. The lower members will be soluble in water because water is a polar solvent. Are you with me? So put these points down. Physical properties of aldehydes and ketones. Physical properties of aldehydes and ketones. That's the next thing we are going to go into now. The physical properties of aldehydes and ketones. Take note of all these structures we've drawn. The physical properties. The physical properties. This is the easiest way to go to enjoy your night class instead of sleeping or discussing with all these chief and more. This is the easiest way to enjoy your night class. All right, let's proceed. The physical properties. Number one, the lower members, or you say the lower aldehydes and ketones, are soluble in water. The lower members are soluble in water. Are you with me? Are you with me? Let's proceed, please. So the first one is that the lower members are soluble in water. Number two, the simplest member of alkanone, or you can say the simplest ketone called propanone. The simplest ketone called propanone is a colorless liquid. Is a colorless liquid, yeah. Is a colorless liquid. Everything that. And it's a useful organic solvent. It's a useful organic solvent. Have you gotten that? It's a useful organic solvent. It's a useful organic solvent. Have you gotten that? Have you gotten that? Remember, I say that they are soluble in water. And I say that the simplest alkanone called propanone is a colorless liquid and it's a useful organic solvent, right? Okay. The next point is that formaldehyde. What's the meaning of formaldehyde? What's the meaning of formaldehyde? Formaldehyde. Who has an idea? Formaldehyde. Formaldehyde. Who has an idea? Formaldehyde. Any idea? Formaldehyde. Any idea? Formaldehyde. Someone say used to preserve dead body. Formaldehyde. Hey, God help me. Oh. God help me na that day. Thank you, Oliverita. Metana. That's what I mean by formaldehyde. Metana. Formaldehyde in bracket metana. Put it that way. Someone said the simplest aldehyde is also good. Formaldehyde in bracket metana. Have you gotten that? Formaldehyde in bracket metana is a gas. Have you seen that? Is a gas. I said something about propanone. That propanone is a liquid, a colorless liquid. And now I'm telling you that formaldehyde in bracket metana is a gas. Full stop. An aqueous solution of formaldehyde is called formalin. An aqueous solution of of, are you with me, please? A natural solution of formaldehyde is called formalin. That's one you use to preserve something. It is used to preserving biological specimen in your lab, in your biology lab. Most of those lizards you see in containers, they have a liquid there. That liquid is formalin, an actual solution of formaldehyde, which is methanol. I don't know the number we are now, but keep on putting something down. Have you seen that? Okay. Have you heard of paraformaldehyde? Have you heard of paraformaldehyde? Paraformaldehyde. Any idea? Put in the chat. Paraformaldehyde. Okay. A solid polymer of formaldehyde is called paraformaldehyde. A solid polymer of formaldehyde is called paraformaldehyde. A solid polymer of formaldehyde is called paraformaldehyde. The question can come this way. The question can come this way. A polymerized solid form of formaldehyde is called dash. A polymerized solid form of formaldehyde is called dash. The answer is paraformaldehyde. Paraformaldehyde. Okay, that's by the way. The next thing we're going to look into is what is called preparation of aldehydes or alkanal. Preparation of aldehydes. Something caught my mind. I think for this period, we can be like, before we have a live class, everybody will send us the topic they want to read for tonight. Do you get? They will now take the topic and teach you instead of carrying your notes and be sleeping. We teach you and trash the whole stuff and give you the comprehensive notes you need. The preparation of aldehydes or alkanal. Aldehydes or alkanal. The preparation. Now, I want you to know this. We may not complete this class. We may not complete this class tonight, but we definitely try and reach somewhere. Then finish it up subsequently. Because this topic is big, yeah. But we try to see how far we can go. The preparation. Now, the first you need to know, that is, before we go into the preparation, you need to have a knowledge of what is called alkanols. Yes. Alkanols that have only one hydroxy group are said to be monohydric. The monohydric alkanols, we have the primary alkanol, the secondary alkanol, and tertiary alkanol. I mentioned three things now: the primary, the secondary, and the tertiary alkanols. Are you with me? Now, this will help us to do something. We can prepare aldehyde from alkanol. Which alkanol? Primary alkanol. Each time we oxidize a primary alkanol, we are going to form an aldehyde. Are you with me? We're going to form what? Aldehyde. If we oxidize the aldehyde further, we now form a carboxylic acid. So the preparation, number one, oxidation of primary alkanol. Oxidation of primary alkanol using acidified K2CR2O7 or acidified KMnO4. Oxidation of primary alkanol. Number one is the oxidation. So what are the reagents we're going to use? The reagents we can use acidified KMnO4, potassium permanganate or potassium tetraoxomanganate 7, or we can use acidified K2CR2O7. Sometimes in exam, they will ask you the oxidizing agent we use to convert alkanol, which is primary alkanol, to aldehyde. This is it, KMnO4, acidified. If they don't want to use the word acidified in the question, they will remove this and replace it with H2SO4. So they can write this way, or they'll put this way, KMnO4 slash H2SO4. H2SO4. Do you get that? Or they will now put it this way, K2CR2O7 slash H2SO4. Take note of that. If you don't put it this way, acidified KMnO4, you now say KMnO4 slash H2SO4. In case you see that in the option. Do you get that? So note, oxidation of methanol gives methanol, while oxidation of ethanol gives ethanol. Write that down. Oxidation of methanol gives methanol, while oxidation of ethanol gives ethanol. Have you gotten that? Number two, oxidation of methylbenzene gives benzaldehyde. Oxidation of methylbenzene gives benzaldehyde. I've mentioned the first method, oxidation of primary alkanol. The second method, oxidation of methylbenzene gives benzaldehyde. It's either you call it methylbenzene or you call it toluene. It's either you call it methylbenzene or you call it toluene. The first method is oxidation of primary alkanol. The second method is oxidation of methylbenzene, also called toluene. Toluene, toluene. Are you with me? Okay. Next one. Reduction of acid chloride. Number three. So we mentioned three different methods we can use in the preparation. The first method is oxidation of primary alkanol. Oxidation of primary alkanol. Example, we have CH3, CH2, OH. Because it can be oxidized to have CH3, C, double bond O, and H. What did we do? The oxidation here is by removal of hydrogen. This is ethanol. This is ethanol. Now, the second method is by oxidation of methylbenzene. Methylbenzene. Instead you call it methylbenzene, or you call it toluene, Tluene, toluene. It will give us benzaldehyde. Benzaldehyde. Okay, someone said I don't quite understand this one. Just give me the exact point you don't understand. It's your right to understand. Tell me the exact point you don't understand. Let's take it one by one. Is it the primary alkanol or the benzaldehyde? Tell me. Which one exactly? Tell me. I want to trash it down now. Which one again? Which one? The number one example. Okay. Someone said number one example. Okay, look at this. What we know as oxidation is either you say addition of oxygen, right? Or you say removal of what? Hydrogen. Right? Addition of oxygen or removal of hydrogen, right? Do you agree with me? Good. Now let's go back to the board. This is ethanol, CH3CH2O. You can see that, right? I want to take the first example. During oxidation, we use this to represent oxidation. This squared bracket holding the O represents that this is about to undergo oxidation. Are you with me? The oxidation here, we are using an oxidizing agent. It will give us. We are going to go to this place, and remove. Are you with me, please? Oxidation involves removal of hydrogen, or you say addition of what? Oxygen. Do you agree with that? Do you agree, please? Do you agree with me? Okay, what are we going to do? This is CH2OH, representing ethanol. CH2OH representing ethanol. If we come here, let's remove these two hydrogen here. This H2, we are taking it out. Are you with me? We are taking the H2 out now. We have H2. What is remaining here? We have remaining is OH. Or you can say, let's remove this hydrogen here. One hydrogen here, one hydrogen here. If you remove one hydrogen from here and one hydrogen from here, so making it two. So we are left here with CH3, CH, and O. I removed this one hydrogen. I removed one hydrogen from here. Are you cleared up to that point? Are you cleared? So we have removed one hydrogen here. We have removed this one hydrogen. So we are left with CH3CHO. And this CH3CHO is called what? It's called what? Ethanol. So this oxygen will be oxidized. H2O. But I don't want to use this method. So I just want you to understand that in this oxidation, it's either you're removing hydrogen or you're adding oxygen. Does that make sense to you? Now, look at the structure of methylbenzene. CH3. This is what is called methyl benzene. Are you with me? Are you with me, please? This is the structure of methyl benzene. If on oxidation, we are going to remove the hydrogen, 2 hydrogen, remove it entirely and add oxygen. We are adding oxygen. If we remove 2 hydrogen here, we are left with H2. If we remove 2 hydrogen, how many hydrogen will remain here? 1. So this is be CH. So this is now we give us CH bonded to a benzene ring. Bonded to a benzene ring. On oxidation, oxygen will be added. This is CHO. An aldehyde group bonded to a benzene ring. We now call it benzaldehyde. We call it benzaldehyde. Please, what I want you to understand now is this. That's benzaldehyde. See there, benzaldehyde. That oxidation of primary alkanol will give us an aldehyde. It is one of the methods of preparing aldehyde. One of the methods. The second point is oxidation of methyl benzene will give us benzaldehyde. Don't forget this, benzaldehyde. Methyl benzene will give us benzaldehyde. Are you cleared now? Are you cleared? Are you cleared, please? Are you cleared? Are you cleared? Are you cleared now? Are you cleared, please? All right, I've gotten it. We have cleared you. Okay. Which other point do we need to know? I've mentioned 2 points. The first one is oxidation of primary alkanol. Second one is oxidation of methyl benzene. That will give us benzaldehyde. The third one now. The third one is reduction of acid chloride. Reduction of acid chloride. Reduction of acid chloride. Have you gotten that? Reduction of acid chloride. Now, it's either you call it acid, reduction of acid or acid chloride. Okay. Let me get my duster to clean this so that we can tackle this thing once and for all. All right, I've gotten it. Look at this. Look at this formula. RCOCl and RCHO. Now, I want you to get to know something now. Look at this. COCl. This Cl is an electronegative element. Electronegative. So this is an acid chloride. Acid chloride. And we say acid chloride. Are you with me? Now, this thing now, for all, you can convert this young man to this. How? Removing this and adding hydrogen. Are you with me? And removal of electronegative element, is it oxidation or reduction? Removal of electronegative. Removal of electronegative. Is it oxidation or reduction? Removal of electronegative element. Is it oxidation or reduction? Which one? Removal of electronegative. Removal. If Oxygen is electronegative, right? If you're removing oxygen, are you doing oxidation or reduction? If you are removing oxygen, are you doing oxidation or reduction? You are doing reduction. Chlorine is electronegative. So if you're also removing chlorine, you are also doing reduction. Take note of that. It's either you call this in acid chloride or you call it acid chloride. Some textbooks we call it acid, so we call it acid chloride. So instead you call it acid chloride or you call it acid chloride. They represent with the formula RCOCl. Example of the compound there is what is called ethanoyl chloride. Leave that for now. Ethanoyl chloride. CH3COCl. Ethanoyl chloride. Are you with me, please? Are you with me? So if we want to convert this acid chloride, also called acid chloride, to ethanol, what we are going to do is simple. Remove chlorine, 1, add hydrogen, it becomes CHO. Whether you are a removal of chlorine is removal of an electronegative element, and it's called reduction. Addition of hydrogen is also what? Reduction. That's why we are saying reduction of acid chloride, or you say reduction of acyl chloride. Does that make sense to you? If it does, please put in the comment section, yes, sir, so that we know that you're following what I'm saying. Are you with me, please? Okay. So if we have this formula is for acid chloride. It's like you call it acid chloride or you call it acyl chloride. This formula is for aldehyde, or you call them alkanal. So if we are converting, look at this, CH3, COCl. On reduction, sometimes they will use a powerful reducing agent, something like lithium aluminum tetrahydride. I repeat, lithium aluminum tetrahydride, which is written as LiAlH4. This one, lithium aluminum tetrahydride. Some will say lithium tetrahydrido aluminate 3. Lithium tetrahydrido aluminate 3. Or you just say, to avoid problem, lithium aluminum tetrahydride. Simple. To avoid problem, lithium aluminum tetrahydride is a powerful reducing agent. Do you get me? But in some cases, they will not just put, in some cases, they will just say Li here, AlH4. So we just say something like this, plus bracket H, just to represent that there is a reduction. Are you with me? To give you, this is showing reduction. This one will go out and combine with this is like having 2 hydrogen. 1 hydrogen will go with this, HCl. What is remaining now? Ca3CO. 1 hydrogen will join here, becomes CH3CHO. Are you with me? 1 hydrogen is joining with this chlorine. So this is ethanoyl chloride. Why this one is ethanol? I remember the time I told them, you want to convert ethanoyl chloride to ethanol. That ethanoyl chloride is an acid chloride or an acid chloride. Are you with me? Okay. We are going to close this now with preparation of ketone. but that will be tomorrow. Just know that to prepare aldehyde, we use oxidation of primary alkanol. If we want to prepare a ketone, we are going to do oxidation of secondary alkanol. Oxidation of secondary alkanol. Are you with me? Are you with me? Very, very important. Very, very important. Very, very important. I think we should touch as preparation of these so that when we come next and we are facing the reactions one after the other. We're facing the reactions. All right. All right. Okay, put these points down. Preparation of what's it called again? Preparation of ketone or alkanone. That'll be the last point we're going to mention. Preparation of ketone or alkanone. Oh, this is where I'm already. Okay, sorry, we are going to pause here. But just take these notes down. Take this note down. Note. Oxidation of secondary alkanol gives ketone. Just put that point down. Oxidation of secondary alkanol gives ketone. Oxidation of secondary alkanol gives ketone or alkanol. Have you written that? Look at how to recognize a secondary alkanol. A secondary alkanol. Look at this. Once you start seeing something like this, propan 2O, butan 2O, butan 3O, those things are secondary alkanol. Yes. But those one that ends with 1O, without saying anything, all of them are what? Primary. Ethanol, butanol, propanol, all of them are primary. But once you start hearing propan 2O, butan 2O, pentan 3O, all those things are secondary what? Alkanol. These are the ones you use to prepare a ketone or alkanone. But use a primary to prepare what? Aldehyde. For example, look at this. CH3, COH, CH3. This thing is propan 2O. On oxidation, this hydrogen will be removed. This hydrogen will be removed. This hydrogen will be removed. So when we remove this hydrogen now, we're going to have hydrogen here. If we're removing this hydrogen now, remove this. We're going to have CH3, C double bond O, and CH3. We have removed these two hydrogens. Are you with me? This C double bond O represents alkanone. So we call it C propan 2O. So this simply means that oxidation of propan 2O gives propan 2O. This propan 2O is a secondary alkanol. It's a secondary what? Alkanol. It's a secondary alkanol. It's a secondary alkanol. Why this one? Propan 2O is an alkanone. It's an alkanone. At this point, someone said further oxidation of alkanol form carboxylic acid gives what? Now, if you oxidize a primary alkanol, it will give you aldehyde. But on further oxidation, it will give you a carboxylic acid. Yes, a carboxylic acid, which is alkanoic acid. So if you oxidize ethanol, We're going to form ethanol, which is an aldehyde. On further oxidation, we now have ethanoic acid. Someone asks, how do we recognize a tertiary? This person is asking, this shows I have not been in my physics class before, actually. To recognize a tertiary, the position of the branch will be the same with the position of the functional group. Example, 2-methyl propan 2-ol, 2 and 2, 2 and 2, 2-methyl propan 2-ol. It is tertiary alkanol. In fact, if you, let me make it easier for you. If you look at a primary alkanol, the carbon holding that OH, we have 2 hydrogen. If you look at a secondary alkanol, the carbon holding that OH, we have 1 hydrogen. If you look at a tertiary alkanol, the carbon holding that OH will not have any hydrogen. Any other question before we close? Any other question? Any other question before we close? Any other question before we close? Any other question? Any other question? Okay. Explain those reactions. Which reaction in particular, please? Which reaction? Which reaction in particular? Okay, I will just ask you a few questions. Question and answer series. Question and answer series. Okay. Question and answer series. The first question says, to know if you can. Question and answer series. Are you ready? Let us brainstorm before we close. Let's brainstorm before we close. The first question says, oxidation of butan 2-ol gives dash. Oxidation of butan 2-ol gives dash. Who has an idea? Put in the comment section. Oxidation of butan 2-ol gives dash. Butan 2-ol. Oxidation of butan 2-ol gives dash. Oxidation of butan 2-ol gives dash. You should know that butan 2-ol is a secondary alkanol. That's the first thing you should know. Butan 2-ol is a secondary alkanol. For this reason, the oxidation will give us an alkanol, which is butan 2-one. O, not al. O-N-E. Oxidation of butan 2-ol gives butan 2-one. Butan 2-one. Take note of that correction. What is the IUPAC name of HCHO? 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 What is the answer? Methanol, Oguruchimobi. That's correct. Next question. What is the IUPAC name of CH3, CH2, CHO? What is the IUPAC name of CH3, CH2, and CHO? Ethanol. Shoma Boniface. That's correct. Next question. When an aldehyde group is readily attached to a benzene ring, it is called dash. When an aldehyde group is readily attached to a benzene ring, it is called dash. What's the answer? When an aldehyde group is readily attached to a benzene ring, it is called dash. Benzaldehyde. Uguruchimobi again. That's correct. Next question. When a carbonyl group of a ketone is attached to a benzene ring, it is called dash. When a carbonyl group of a ketone is attached to a benzene ring, it is called dash. When a carbonyl group of a ketone is attached to a benzene ring, it is called dash. Shoma Boniface, that's correct. Phenone. Next question. Acetophenone is also called dash. 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 Who has the answer? Acetophenone is also called dash. Acetophenone is also called dash. You've not gotten it. No, Ujunwa, you tried. That's not the correct answer. Give the position, Dorcas, you tried. Not just phenyl ethanol. No. That's wrong, please. That's wrong. Put the position. 1-phenyl ethanol. 1-phenyl. Ujunwa, take the correction of the spelling. It is PHE, not PHY. That's correct. 1-phenyl. Wrong, please. Not phenyl ethanoids. Phenyl ethanol. 1-phenyl ethanol. Next question. Benzophenone contains how many benzene ring? Benzophenone has how many benzene ring? Benzophenone has how many benzene ring? Benzophenone. Prince, okay, that's correct. Two benzene ring. Next question. Now, primary alcohols can be converted to aldehyde by a dash. Option A, reduction. Option B, partial oxidation. Option C, esterification. Option D, hydrolysis. Primary alkanols, yes, they are converted to aldehydes by oxidation. Not a complete oxidation though, by partial oxidation. By partial oxidation. Yeah, that's correct. Partial oxidation. Next question. Partial oxidation of methanol gives dash. Partial oxidation of methanol gives dash. Partial oxidation of methanol gives dash. Partial oxidation of methanol. Methanol is a primary alkanol. It will not give you alkanol. It will give you an aldehyde. It will give you methanol, also called formaldehyde. Uguruchimobi, that's correct. It will give you formaldehyde, which is called methanol. Docas Godfrey, that's also correct. Methanol. Next question. Oxidation of methylbenzene gives dash. 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 Benzaldehyde. Peace fever, that's correct. Benzaldehyde. Next question. We're going to call it a night. We're going to stop here, please. We're going to stop here. 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 Thank you guys for staying to the end. You guys are amazing. You guys are amazing. You guys are amazing. You guys are amazing. There are some important points we should also try to touch maybe in our next class. I decided to cut this class here so that you now go and look at it again. Look at the basics. Do you get? Now we're going to look at other reactions as well. Maybe nice life class we're going to have maybe on parasitology actually. Question and answer series on parasitology, or we pick let's say biology, anyone, or likely physics. And do something good. And do something good. And do something good. Oh God. You have spent up to 2:16 a.m. West African time, 2:16 a.m. of the West African time. It's not really easy. That shows that you guys are ready to learn. And I will do everything humanly possible so that to make sure you guys are carried along. See you next time. Thumbs up, thumbs up, thumbs up. Do well to say something in the comment section. If you really enjoyed this live up to this moment, say a moment of word of encouragement to us. We spent our time, we spent our energy to make sure you are here. Good night, and good morning, depending on your location as well. Bye.